Hello. So in this segment, we are going to be putting together inequalities without sort of ruining the inequality bit, meaning like we want to preserve the actual inequality relation. So I want to show sort of a nice way of doing this kind of thing so that we can sort of do it even with annoyingly complicated expressions, right? So here we have this like expression less than an expression, and then that expression greater than that expression. So what I'm going to do is write down basically like a simple version of this, just using like an A, B, C, and D kind of deal. So I'm going to start by saying, okay, if I have, let's say, A, in fact, I'll even try to color coordinate this if I can, less than B, and let's say, I don't know if I have enough colors, so C less than D. Okay. So if I have these colors, these sort of setups, right? So I have A less than B, C less than D, these inequalities. If I want to add these things together and I want to not ruin the relationship, right, then I need to add the smallest pieces together and the biggest pieces together, because if I add the smallest things together, I'm going to get the smallest possible combination. And if I add the biggest things together, I get the biggest combination. And so the bigger combination is still bigger than the smallest combination, right? So the idea is I sort of try to go toward the worst case scenario kind of deal. So if I have this relationship then, and I want to put them together, I can do A plus C is less than D. Let's try actually maintaining this, huh? E, there we go, plus D. Okay. So this is the way that you can put inequalities together. And this is true no matter what A, C, B, and D are, this will work, okay? So in particular, all right, I've not talked about these inequalities at all, so like, why do this? Well, now I can write down what is A, what is B, what is C, what is D. I have to be a little careful when I do that, but once I write down those expressions, then I can just basically plug into this, and I know I'm not going to make any mistakes. So let's start with, let's say, A. In fact, I'll do it over here. So A, I'm going to make A into one of these expressions. And the thing I want to be careful of is that I sort of respect how these inequalities are written when I first wrote them down. So A has to be on the less than side of one of these pieces. And just as an aside, I want to comment, like, this is true as well as less than or equal. Like, whether it's less than or equal or less than, that relationship is true either way. I'm using less than because that's sort of, I have strict inequalities in my actual problem. So I'm just going to use strict inequalities here to sort of hopefully minimize confusion. But there's no reason they have to be strict, just to be clear. Okay. All right, so A, I want it to be on the less than side. So looking up here, that thing is less than that thing. So I'm going to make that one A. So A is square root of 18x and minus 6. Okay. B, well, B, this wants to be, right, this needs to be on the greater than side. So I'm going to pick the top one. The greater than side is on this right-hand side. So I'm going to make it minus 3x minus 1 squared, or is that cubed? Cubed, sorry. Cubed plus 6. Then for C, again, I want to be careful here. So C is also on the less than side. I've already done the top inequality, right? I've got both of those. So now I'm going to do the bottom one, but I don't want to do the thing on the left, right? Even though this one's on the left, I want it to be on the less than side. And if I look up here, the left hand side is actually on the right. So I'm going to make it this one because this one is on the less than side. So I have minus 9 times x minus 2 cubed minus 4. And finally, I have D. And D, right, is on the greater than side. If I've done all this right, it should only have the one option, which is this 18x minus 6, because I've accounted for all the other ones, right? And of course, it is a good sign that, right, that is on the greater than side, just like I wanted that one. So now I have A, B, C, and D. So all I got to do is write this inequality, right? So I'm going to take my A, square root of 18x minus 6 plus C. So then plus, so just, I know it's color coordinated, but just to be clear, it's always good to throw in parentheses. So then I want C, so that's going to be negative 9 square root. That's not a square root, sorry. My brain was totally on autopilot. Happens to all of us. X minus 2 cubed minus 4. And that is going to be less than B. B is minus 3, x minus 1 cubed plus 6 plus D, right? Plus D. And D is 18x minus 6. And that's it. This is my inequality right here. So like if I sort of needed to, I could then go about trying to sort of clean this up, right? I could try to simplify this or whatever, but that's not what my question asked. My question was just like, give me one that combines these two, right? Adds these two together and gives me this thing, right? Mission accomplished. So there we go. That's it. Hello. So in this segment, we are wanting to subtract these inequalities, again, with preserving the inequality sort of nature without messing anything up. So again, I'm going to use sort of my standard tactic for this. I'm going to start by just writing this out using like an A, B, C, D, you know, like general letters. And that way I can sort of assign each letter to one of these expressions and then just sort of copy in and do it. That way I don't have to worry about messing up what's, you know, going where. So to that end, I'm going to develop one for subtracting. So in general, if I have something like A less than B and C less than D. Now what I want is to be able to subtract these things and end up with something that's valid. Now, again, generally speaking, I sort of use my intuition, I use my sort of logic to go through this, meaning that if I start with something that is small less than big, right, and I want to subtract stuff, but I don't want to subtract the same thing, that would be sort of easy, then I'd know it would work. If I have like two other numbers that I don't know, one smaller than the other, well, if I subtract the biggest thing from the smallest thing, that'll give me the smallest possible thing, right? Because I end up with sort of the thing that's sort of to the left on the number line. If I subtract an even bigger thing from this thing than I do from that thing, they'll stay in that same relationship. Meaning that if I take A less than B, then subtracting D from A, right, as opposed to subtracting C from A, subtract the bigger thing will give me the safest bet. And so I end up with something like A minus D on one side is less than. And likewise, if I take the biggest thing that I have out of the two and subtract the smaller of the two, that'll give me sort of the best possible large side, right? As opposed to subtracting something even bigger, that'll give me something smaller. I don't want that. I want the biggest possible out of subtracting one of these two. So I'm going to subtract the smaller one. So I'm going to take B minus C. Okay. And now, right, now that I know the relationship I'm after, I'm going to go ahead and write out the A, B, C, and D, assign them one of these expressions, like each one of them gets exactly one of these expressions, and then I can just fill in. So I'm going to have A, B, C, and D. Okay. And again, I want to be very careful about paying attention to the inequality as I wrote them when I wrote down the A, B, C, D. Because I could do this like I usually do, like less thans, but there's no reason I couldn't have done like A greater than B, C greater than D, and then still sort of, I would have ended up with this formula if I sort of logicked it correctly in my head, right? I would have still done biggest from smallest. It's just which one was bigger and smaller would look different. But I would have come up with a valid formula. But the key here is that I want to look at my expressions and make sure I match up with the symbols, right? So for example, A is going to be on the less than side. So when I look at my options, I have that this thing on the left, on the top, right? That's on the left, on the less than side, as is the thing on the bottom to the right, right? That's also on the less than side. So I could do either of those as my A, and I'm just going to pick one. It honestly doesn't matter which one I pick. So let's pretend for a second that I pick the second one, right? So picking that one, I would get minus 40 times x minus 2 squared minus 1, right? Same deal with B. B needs to be now the thing that is bigger than A, right? That was the rule of thumb here, is that A and B are related where A is the small one. So if I pick this one for A, I need to make sure that I pick that one for B, right? That's the whole point. B has to be bigger than A. I know that that thing is bigger than what I picked for A. So B then is 2x plus 12. Now, same sort of deal, C, right? I've already done the bottom inequality fully now, so C would have to be the top inequality, but again, I want to make sure I line these up. So C is on the less than side, so C is going to be this thing, right? Because that's on the less than side. So I'm going to get 5 times x minus 4 squared plus 3. And likewise, D has to be the thing that is bigger than C. So if I go back up here, right, my C is there, my D is the bigger than. So D is negative 7 times 3x minus 5 cubed plus 1. Okay. And now I just take my definitions, A, B, C, and D, and plug them into my expression. So A was negative 40 times x minus 2 squared minus 1. And then I am subtracting, right, minus D minus 7 times. And here, as a note, it actually is really important that you use parentheses, right? Because that negative is going to get distributed if I were to simplify this, right? So that plus 1, my cube, that plus 1 is really a minus 1, right? Because the negative here would expand, right? It would go to both pieces. So always a good idea to throw in parentheses when you're substituting a term in, because you're vastly less likely to make any kind of error that way. So then I know this is less than B, which is 2x plus 12, minus C, which was 5 times x, minus 4, not plus 4, x minus 4 squared plus 3. Okay. So again, I've just taken this relationship, A minus D, right, with A and D, less than B minus C, B and C, B minus C. That way I don't have to worry about sort of trying to do it all at once, like in my head, and keep track of what side's doing what. I just sort of do this to make my pattern, define my terms so I don't mess anything up when I'm doing the substitution, and then substitute, and I'm good. Okay, so there we go. Hello. So in this segment, we want to combine these two inequalities, right? We want to, in particular, subtract in order to put them together, but in a way that preserves the inequality, right? So as usual, I'm going to do my A, B, C, and D thing. I'm going to develop the right relationship using A, B, C, and D, define them as these expressions, and then substitute to put them together. That's the overall game plan. So Don't mind me dropping stuff. As we, so as usual, starting, I'm going to have my, right, A, if A is less than B, and let's go with C less than D. Okay. So this thing specifically wants me to do subtraction, right? So the idea, right, is to take the smallest, right? If I take one of them, I want to subtract the other one. My options would be subtract C from A and D from B, or subtract D from A and C from B. And basically, I always want to take the sort of best case or worst case, depending on your point of view, scenario that sort of stretches these apart, right? Makes this one further left and this one further right to the best that I can. So to that end, if I subtract the biggest thing possible, right? If I subtract D from A, that'll go as far left as possible. That's what I want. If I subtract C from B, that'll go sort of as far right, right? It'll go the least left from B as possible, meaning that I will sort of stay closer to the right by subtracting the smaller as opposed to the bigger. So what that tells me is I want to do A minus B, minus D. So, right, I want to subtract off the bigger of the two. And that way I will still have something that is less than. And from this side, I have B minus, and then I want to subtract the smaller of the options, so B minus C. Okay. This is the sort of general format, so applying it to this, right, because these expressions are awful, I don't want to like do all of that in my head. Instead, I'm going to write out what A, B, C, and D are explicitly, so I can just reference them basically. Again, always being careful that when I do that, I make sure to match up as I wrote the initial sort of inequality. That's why I don't want to just skip to this. I need to make sure that I have these two lines written down so that I know how to define the things up here, okay? So A has to be on the less than side, so I can make it be this term down here, right? Because it's on the less than side for the bottom part. Or I could be on this side, because that's on the less than side of the top. So it doesn't matter which one I choose. I guess I'll choose the top, why not? So this is x minus 1 cubed and minus 9. Now, once I've made that choice, though, now B is kind of forced, meaning that B has to be the thing that is greater than A. I don't actually know anything about either of these two bottom inequalities as it pertains to, any of these two bottom expressions in the bottom inequality as it pertains to that top left, right, what I've now labeled A. So I have to make this other one B, because that's the thing that I know is greater than what I've now labeled B. So for my B, I'm going to get 3 square root of 2x minus 5 plus 9. And then C, well, C, so C has to be, again, on the less than side. I've already done the top inequality, so I'm doing the bottom one now. But the less than, right, is this side down here, right? So it's on the right, even though I've written it on the left here. That's not the important part. The important part is that I match up the less than. So this is going to be 9 times 3x plus 2 cubed minus 6. Okay, and then last but not least, D. D has to be the thing that is bigger than what I've now labeled C, so that leaves me just, fortunately, the one thing left, right? So I get 4x minus 2 squared. All right, so now that I've done that, right, now that I have them all defined, I have my relationship, now I can use that and plug in these things, right? So I want to do A first, so A, that is minus 6 minus 1 cubed minus 9. And remember here that now it actually is important that I use parentheses, right? Because I'm going to end up needing to distribute the negative sign. So I have A minus D, so that's going to be or I should say I will potentially distribute a negative sign. It all depends on what I've actually labeled as A, B, C, and D, really. So I have that, then I'm going to have less than, and now I have B up here. So that is 3 times square root of 2x minus 5 plus 9. And then I'm going to subtract off C. C is 9 times 3x plus 2 cubed minus 6. Okay, and again, I could simplify this. I mean, some of this stuff would actually simplify kind of nicely potentially, but the point is I don't need to, right? All it asked for was to build an inequality by combining these two things using subtraction in a way that preserved the relationship. I've done that, problem solved, right? Don't do extra work unless you have a purpose, right? That's a key idea in math. Once you finished what was asked, stop. Don't keep going and potentially introduce errors. But by the same token, make sure you've done what was asked, right? So develop the relationship, right? A, B, C, D. Define what those things are using your actual problem, right? Using all those expressions, and then substitute. All done. Okay, so that's that.